It's such a beautiful day, isn't it?
I know, right? It's just like, it's the perfect temperature and the plants are thriving. It's not too rainy, nothing.
Yeah.
Oh, hello there. I'm Anthony Larsen.
And I'm Kyle Larsen.
Today we will be learning about the pH scale and how it affects your plants.
We will also be going over how too much acidity or too little acidity will affect your plants. And we will also be providing 2 experiments you can do at home.
The first thing you need to know is what is pH and what is the pH scale. pH is something used to measure how acidic or how basic something is. This is measured on something called the pH scale. As you can tell, it ranges from 0 to 14, 0 being the most acidic, 7 being neutral, and 14 being basic.
Perhaps you have realized after eating something sour or strong, you notice that your mouth tends to salivate more, or in other words, you pucker your lips. This is due to the high concentration of citric acid in that food, this being more acidic than your typical food or drink.
The pH of soil is different because it is fairly difficult to measure. You can usually tell what the general pH is if you look at the plants around it, whether they are dying or if they are more healthy.
It is important to monitor your soil's pH because it can impact the health of your plants inside of it. It can cause the leaves to either brown and die, or it can produce less flowering fruit on the plant.
Soil pH is also important because the death of a plant can contaminate the soil, therefore creating a less suitable environment for other plants. Plants that need a very high soil acidity, such as blueberries and basil, are usually kept in soil acidities in the 4.5 to 5.5 range, which is considered a highly acidic pH in soil. Soil's pH does not hit the polar ends of the pH scale, usually because plants tend to grow in the 4.0 to 8.0 pH levels.
For example, plants like asparagus or garlic need a pH range of 6.0 to 8.0 in order to thrive during their growing season. If this requirement is not met, there is less of a chance of getting the maximum production rate of crops available, or any at all. To test your soil's pH, you don't need any fancy equipment at all. There are 2 very simple experiments that you can do at your home, including items that are very inexpensive and not very hard to find.
The first one includes a simple pH test, like this RAP test, that you can get at your local hardware store, like Ace Hardware. Ace is the place with the helpful hardware, folks.
This is a very simple test in which you can perform using items from your own kitchen.
Here we have a sample of soil and we have a half cup of vinegar. I'm going to pour this inside of the soil, and if the soil fizzes, then it is alkaline soil having a pH of 7 to 8. But I don't see any fizzing here, so nothing is happening. It is not alkaline soil.
Now with this sample of soil, we will take some distilled water and pour it inside of the sample. Next, we will add a little bit of baking soda into the sample. We will stir it, and if it fizzes, then that means that this soil is acidic. It is fizzing, if you can see that. So that means this soil is acidic. So here's the final product. This is actually soil that we took from the blueberry and basil bed, in which that needs acidic soil.
The rapid test that I showed you from earlier contains this container and these capsules. You empty the capsule into the container, which contains a white powder. Then you will hold the soil that we used from earlier and mix it with distilled water with a ratio of 1 part soil and 5 parts distilled water. Then you will shake it up and let it settle. Now we will use a pipette and take the water where there's no soil chunks, and it's the clear liquid. Now you're going to put it into this container until it fills up to the water line. And this may take a little while. And there we go. Now you shake it up, and then you let it sit for 1 minute. So you're going to shake like this.
We're going to do the exact same thing with the soil we took from the blueberry and basil bed, which that was the soil that fizzed in the previous experiment. So we will take the very top of the container of water, which contains no bits of soil, and fill to the water line. And there we go. And now we will. Oh. No. Sorry about that. We will shake it up. And now we will leave it to settle.
As you can see, the first sample has more of a green color, which corresponds with a neutral pH.
And sample 2, it resulted in acidity levels between 6.0 and 6.5, which is more acidic than sample 1. As you can see, the pH scale extends well beyond the science lab.
It is included in all of the foods that we grow and eat every single day. We hope that you enjoyed learning about pH, and I hope it helped you a lot.
Okay, boys, wrap it up.
Jeez, Mom.